So as discussed before, these are the parts for a light bulb. Now, an incandescent lamp has two terminals, base and the electrical contact. These two terminals are connected to the extremities of a tungsten filament, as you can see. Okay, so if a voltage is applied across the terminals of the light bulb, the filament will have enough energy and it starts emitting light due to the excitation of the atoms. So now for a light bulb to glow, voltage must be applied across its terminals, which are the base and the electrical contact. So this is the rule. Now, how to light a lamp without using a socket? A lamp is connected directly to a dry cell without using connecting wires. In each of the cases shown below, explain why does the lamp glow or not. So we have to refer to the rule, which is applying a voltage across the two terminals of the light bulb. In case A, we can see that the positive terminal of the battery is connected to the electrical contact of the light bulb. However, the negative terminal is connected to the glass bulb. So no voltage is applied across the terminals of the lamp. That's why the lamp doesn't glow. So the negative terminal of the battery is connected to the glass bulb instead of being connected to the base. In B, the light bulb glows because the positive terminal of the battery is connected to the electrical contact and the negative terminal is connected to the base. So there is a voltage applied across the terminals of the light bulb. That's why the light bulb glows. In C, the two terminals of the battery, the positive terminal and the negative terminal of the battery, are connected to the electrical contact of the light bulb. So actually the one should be connected to the electrical contact and the other should be connected to the base, but this is not the case. That's why the light bulb doesn't glow. So both terminals of each battery are connected to the electrical contact of the bulb. As for D, regardless of the orientation of the spatial orientation of the lamp, we have that one terminal of the battery is connected to one terminal of the lamp and the other connected to the other terminal of the lamp. So here the positive terminal of the battery is connected to the base and the negative terminal is connected to the electrical contact. So a voltage is applied across the terminals of the battery and that's why the light bulb glows. How to light a lamp without using a socket. A lamp is connected to a dry cell using connecting wires. In each of the two cases shown below, explain why does the lamp glow or not. So now instead of connecting the light bulb directly to the battery, we are using connecting wires. You know that connecting wires are mostly made up of copper that are insulated by an insulating material in order to protect the user. So only the ends of the wire is not insulated. However, the other part is insulated to protect the user. Anyway, here we have that the positive terminal of the battery is connected to the base and the negative is connected to the electrical contact. As you can see, that's why this means that a voltage is, this is a closed circuit, current can flow through the circuit and the voltage is applied across the terminals of the light bulb. That's why it glows. So one of your friends asked me, okay, could we consider the base to be always the positive terminal and the electrical contact to be the negative terminal of the lamp? I said this is not true. It's not a rule. In order to determine which one is positive and which one is negative, we have to follow the direction of the current. So you know that the current comes out of the positive terminal of the battery. So it goes now, the positive terminal is connected to the base in this case. So the current is going to go from the base to the electrical contact to the wire and back to the negative terminal of the battery. So it's going from the base to the contact. That's why we consider the base to be the positive terminal and the contact to be the negative terminal. However, if we had the positive terminal connected to the electrical contact as shown here instead of the base, and the base connected to the negative terminal, okay, we know that the current comes out of the positive terminal of the battery. Now it's going to reach the electrical contact before it reaches the base. So actually it's flowing from the contact to the base. So now the contact is positive and the base is negative and it continues its way to the negative terminal of the battery. So the negative terminal of the battery is connected to the electric contact of the bulb through conducting wire. Similarly, the positive terminal of the battery is connected to the base of the bulb, thus the lamp glows. What about the second one? Though it appears that a voltage is, or the two terminals of the battery are connected respectively to the two terminals of the lamp, but still the lamp doesn't glow. The point here is that you can see that the other end of the wire that's connecting the negative terminal of the battery to the contact of the light bulb is also insulated, so current can't actually pass it through. And similarly, the wire connecting the positive terminal of the battery to the base of the light bulb is also, here insulated from the other side. So there is no direct contact between the terminals of the lamp and the wire that's connecting it to the battery. So that's why no current could pass and light bulb doesn't glow. So here the insulating cover of the two wires are connected to both terminals of the light bulb, and that's why the lamp doesn't glow. These are sockets of a light bulb. As you can see, it has two terminals. So internally, this terminal one is connected to the base, and the other terminal is connected to the electrical contact upon when the light bulb is inserted in it. See here another type, another form of a socket light bulb socket can feed two terminals coming out of it, the black for one and the white for the other. Third one here, also having two terminals, so that upon inserting it in the wall outlet, voltage is applied across the terminals of the light bulb and thus it glows. So now how to light a lamp using a socket. So first we started without a socket, without a wire, then we studied when connecting it to a wire. Now using a socket. So connect the two terminals of the socket to the two poles of the dry cell by means of connecting wires. So in this way one of them is connected to the base and the other is connected to the internally to the contact. So we have a closed circuit that allows the flow of current and thus the lamp is lit. However, in this case, when we connect only one end of the lamp socket to one pole of the dry cell, this is not enough. No closed circuit is formed. The circuit is opened and the lamp doesn't glow, is not lit. Moving to the batteries or to the dry cells, because we've been talking about light bulb connected to a dry cell. So let's have a brief let's talk briefly about dry cells. Dry cells are available in different forms and with different voltages. So you can see here the first one has 1.5 volts indicated on it. So it provides 1.5 volts. The other one here has 9 volts. The battery or the dry cell of the cell phone is 3.6 volts. That of the car is 12 volts. So it depends on the usage of the dry cell. If it is used to allow the functioning of a small electric device like the remote control, for example, we need 1.5 volt. We need because to function the car, all the electric devices in the car, we need a 12 volt dry cell. Now these are the indications on the dry cell. What about the indications on the light bulb? We can see that we have here indication 12 to 24 volt only. We have here 220 volts. This is another lamp that has 3.6 volt, 0.75 ampere indicated on it. So what do these indications mean? These indications mean that, for example, this lamp can burn only or can function normally when a voltage of 12 to 24 volt is applied across its terminals. This one, for example, needs 220 volts to function normally. This one needs 3.6 volts to function normally. So we call these indications rated voltages and rated currents. So the voltage indicated on a lamp is called the rated voltage, or we call it the nominal voltage. By definition, the rated voltage is the voltage needed by the lamp to function normally, and the rated current is the current that passes through the lamp during normal functioning. So the functioning of a lamp is maintained by voltage applied across it. So for example, if the rated voltage on the lamp is 220 volts and you connect it to a dry cell that provides only 9 volt, would it function normally? For sure not. Here the lamp is taking less voltage than needed, so U lamp is less than U rated. That's why the lamp glows weakly. However, if you connect, for example, a 220 volt cell to a 220 volt, for example, a light bulb, so the voltage received by the lamp is equal to its rated voltage, then the lamp is going to glow normally. And finally, if the lamp receives a greater voltage than needed, like if we go back to this, if we connect now this lamp directly to a dry cell like this one that provides 9 volts. So if the lamp receives 9 volts, however, it needs 3.6 volts to function normally. Its rated voltage is 3.6. It's going to be burnt. It's going to glow brightly and maybe be burnt out as time passes. So when a lamp burns out, the tungsten filament burns out here and acts as an open switch. So the terminals are disconnected from each other. The base and electric contact are no more connected through the tungsten filament. So here we have an open switch. So burnt lamp acts like an open switch. And this is a diagram that explains what happens when a lamp is burnt. So if we have series grouping of two lamps and L1 gets burnt, for example, it opens because the filament burns out and the other one doesn't function. However, if the grouping of the two lamps was parallel, this burnt lamp that's acting as an open switch doesn't affect the functioning of the other one because still we can see here that there's a closed circuit for the current to pass through L2. That's why L2 remains functioning in the same manner, receiving the same voltage from the battery.